Hi, I'm Jimmy Chang, and we're here to talk about how to do proportions with three variables. Now, when you're encountering three variables in proportions, one thing you want to consider is there's a lot to kind of take care of, and frankly, the kind of proportions that you can simplify are really the ones that are separated by multiplication and or division, because addition and subtraction, your options are kind of limited when it comes to simplifying proportions. So let's do an illustration and you'll see what I mean. So suppose you have x cubed y to the fifth z to the 10th over x to the fourth, y cubed, z to the 7th. Now, like I said, these terms are separated by multiplication and division. If it was separated by addition or subtraction, you pretty much have to leave it as they are because you can't really simplify too much with that. However, since they're all multiplied together, what you can think about is you can look at the variables with like bases and you can simplify the respective exponents from there. Now, we'll get to the x's a little bit later on because the denominator exponent is larger, but if you look at the y to the fifth and y cubed, you can subtract the 3 from the 5, and you're left with y squared, and then z to the 10th and z to the 7th, same idea. They cancel out, and you're left with z to the 3rd. Now, what you're basically doing is you're subtracting the larger from the smaller from the larger. Now, here, because the 4 is larger than the 3 and the 4 is at the bottom, you're pretty much canceling it down here, but the denominator exponent is going to remain, and there's going to be x to the 1, which you don't really normally write. So the final simplification here is going to be y squared z to the 3rd over x. So when it comes to doing proportions with three variables, you just want to be sure that the terms are separated by multiplication or division before we can really simplify much of anything. So I'm Jimmy Chang, and that's a brief introduction on how to do proportions with three variables.